All right, so we hear it all the time, right? This AI is super smart, or that one has insane accuracy. But what does that really mean? How do we actually grade these things? Well, today, we're going to pull back the curtain and look at the real report card for AI. This is how we separate the true geniuses from the lucky guessers. Let's get into it.
Yeah, I mean, this is the big question, isn't it? How can you tell if an AI is actually smart? It's not like you can just hand it a test and get a simple grade back. It's a bit more complicated than that. To really get a handle on how well an AI is doing, you've got to look at its performance from a couple of different angles.
So probably the best way to think about this is to imagine a student, right? You've got your homework, which is all about learning and practicing, and then you've got the final exam, which is where you prove you actually know your stuff. AI models, they're graded in almost the exact same way. They have two completely different report cards for two very different jobs.
Okay, so on one side, you've got the metrics that guide the model while it's training. Think of this as the teacher's red pen on the homework. It's constantly telling the model, hey, you're getting warmer, or nope, try again, you're way off. Then, on the other side, you have the evaluation metrics. This is the final exam. This is the grade it gets when we show it brand new problems it's never, ever seen before.
All right, so let's dig into that first report card, the one for the training process. The biggest trap here, and it's a huge one, is making sure the AI is actually learning the rules of the game and not just memorizing the answers to the practice questions. And the main metric we use for this is something called loss. Honestly, just think of it as an error score. It's one simple number that basically screams at the model how wrong it was. The entire point of training is just to make that number as small as possible. Push it down towards zero. Okay, but here's the catch, and this is super important. We don't just look at the loss on the stuff it's training on. We have a secret stash of data, the testing set, that the model never gets to see during practice. The training loss tells us if it's doing its homework, but the testing loss, that's what tells us if it can actually ace the final. It's the true test of whether it can take what it learned and apply it to something new. And this is where it gets really cool because you can watch these two numbers and they tell a story. If both the training and testing loss are going down together, awesome, perfect. That's what we call a good fit. But if you see that training loss dropping like a rock while the testing loss starts to sneak back up, uh-oh, that is a massive red flag. That's called overfitting. And it's the classic sign of a model that just memorized the homework and completely choked on the final exam. Okay, so let's say training is done. The model has studied. Now it's time for the final exam. How do we grade that? Well, this is where we switch over to our evaluation metrics. And to understand any of them, you have to start with a really simple idea. For any basic yes or no question, there are only 4 ways things can go.
And to make this super clear, let's use a really high-stakes example. Imagine an AI whose job is to screen patients for a serious disease. So, if the AI says positive, that means it thinks the patient has the disease. If it says negative, it thinks they're healthy.
First up, you've got a true positive. This is exactly what you want for a sick patient. The model says, you have the disease, and it's right. The patient does have the disease. Perfect. That's a huge win.
And just as good is the true negative. This is for a healthy patient. The model says, you're all clear, no disease, and again, it's correct. The patient is healthy. Phew, everyone can breathe a sigh of relief. Another win.
All right, now let's talk about the mistakes. A false positive is basically a false alarm. The AI says, you have the disease, but oops, the patient is actually perfectly healthy. This is going to cause a lot of stress, maybe some unnecessary tests, but in the grand scheme of things, it's not the worst mistake the AI could make. Because this is the one that keeps doctors up at night, the false negative. This is when the model says, you're fine, go home, but the patient is actually sick. This is a terrible miss. It's incredibly dangerous. And this is the key takeaway, right? Not all mistakes are equal. Some are way, way worse than others. So how do we keep track of all this? We use something called a confusion matrix. I know, it sounds kind of complicated, but it's really not. It's just a simple box that organizes those 4 outcomes. It puts what the model predicted on one side and what was actually true on the other. This little box is the foundation for pretty much everything that comes next. Okay, so now that we have our confusion matrix, we can start calculating some actual scores. We can build our report card. But the big question is, which score do you use? Because, and you're going to see this in a second, the most obvious and common metric is often the absolute worst one to use. And that metric is accuracy.
I mean, it sounds perfect, doesn't it? It just answers one simple question. Out of all the predictions, what percent did the model get right? You just add up the good stuff, the true positives and true negatives, and divide by everything. Simple. Easy. What could possibly be wrong with that? Well, let me ask you this. What if I told you an AI had 99% accuracy? You'd be pretty impressed, right? I mean, that's an A+. It sounds almost perfect. But that beautiful number can be hiding a really, really ugly secret. Okay, let's switch gears to a spam filter for a sec. Imagine your inbox is like 99% real emails and only 1% is junk. A really dumb, lazy AI could just predict not spam for every single email that comes in. And guess what? It would be 99% accurate. But it would also be completely useless because it's letting all the actual spam right into your inbox. This is the accuracy trap, and it's exactly why we need better tools. So let's bring in the specialists, precision and recall. These two metrics look at the problem from totally different angles. Think of it this way. Precision asks, of all the times you pointed a finger and yelled spam, how often were you actually right? Its whole job is to avoid false alarms. Then you have recall, which asks, of all the spam that actually existed, how much of it did you manage to catch? Its job is to avoid missing anything important. So back to the spam filter. Think about it. The cost of a false positive, a super important email getting thrown in the spam folder, is huge. That could be a job offer, a message from family, you name it. So for a spam filter, you need high precision. You want it to be really sure before it calls something spam. You'd probably rather have a couple of junk emails slip through than lose one important one. But for that medical AI we were talking about, it's the complete opposite. The cost of a false negative, telling a sick patient they're healthy, is absolutely catastrophic. In that case, you need high recall. You want to cast a wide net. You want to find every single possible case, even if that means you get a few false alarms that you have to double-check later. So you see the problem, right? There's this constant push and pull. Do you focus on avoiding false alarms, or do you focus on not missing anything? What if you can't afford either type of mistake? Well, what if you need to do both? That's where we get to the ultimate balancing act. And for that, we have the F1 score. This thing is brilliant. It's a single score that magically blends precision and recall together. It's specifically designed to give a high score to models that are good at both, and it will crush the score of any model that's lopsided. One that has amazing recall but just awful precision. I mean, just look at this. Model A has fantastic recall. It finds every case, but its precision is in the gutter. It's raising false alarms all over the place. And look at its F1 score, a terrible 0.18. Now look at Model B. It's got a really nice solid balance between precision and recall. It's not perfect at either, but it's strong at both. And its F1 score? A beautiful 0.90. That is the model you want every single time. So from now on, when you see some headlines screaming about an AI with 99% accuracy, you're going to know better. You'll know that shiny number could be hiding a fatal flaw. And hopefully you'll be the person in the room who knows to ask the real question. That's great. But what's its F1 score?